Welcome to the Explainer. Today, we are diving into one of the biggest, most important leaps forward in AI, reasoning. This is the tech that's turning our chatbots from, glorified parrots into actual problem solvers. So, let's get right into it.
But first, let's start with a feeling I bet a lot of you have had. You ask your favorite AI to write this amazing poem about, say, a sunset, and bam, it does it in seconds. It's beautiful. Then you give it what seems like a simple math word problem from a middle school textbook, and it just completely fumbles. It's super frustrating, right? And it points to this really fundamental gap in how standard AI models work.
And yeah, that brings us right to the heart of the problem we're talking about today. The limits of what we call vanilla large language models. I mean, these things are incredible with language. They are true linguistic savants. But when it comes to any kind of multi-step logic, they can be total novices.
And these vanilla LLMs, they have some pretty major blind spots. Sure, they seem to know everything, but their ability to reason through complex problems is actually pretty weak. Their knowledge is frozen in time, they can't actually do anything in the real world, and honestly, it's really hard to even tell if their free-form answers are right or wrong. But today we're going to laser focus on that very first weakness, their limited ability to reason.
So the big question is, how did developers and researchers even begin to fix this? Well, the breakthrough came from a surprisingly simple, almost human idea. What if you could just make the AI think out loud? This is the core concept behind what's called chain of thought, and believe me, it completely changed the game.
Okay, so before we go any further, let's just make sure we're on the same page. When we say reasoning for an LLM, what are we really talking about? It's the ability to solve a problem that needs to be broken down into smaller pieces. Just think about how you tackle a tough question on a test. You don't just magically know the answer, right? You work through it, step by step. That is exactly what we want the AI to learn to do.
And wow, this slide just perfectly shows the difference. Look on the left. The vanilla LLM sees the numbers 2020 and 2025, and it just sort of guesses a plausible sounding but totally wrong answer. But now, look at the right. The reasoning LLM first generates its thought process. It says, okay, the current year is 2025, the birth year is 2020, the operation is subtraction. It literally shows its work, and by doing that, it gets to the right answer.
So here's the magic of why this actually works. LLMs, at their core, are just really good pattern matchers. A big, complex problem might be something it's never seen before. But the individual tiny steps, like simple subtraction or identifying a date, those are patterns it has seen millions of times in its training data. So by breaking the big problem down, the model can just solve each little piece one at a time. It's genius.
So it's one thing to see this work in a single example, but how do you actually teach a model to do this reliably, at a massive scale? Well, it takes a completely different approach to training. It's a shift from just having the model guess answers to having it actively verify them.
And this is where developers kind of hit a brick wall at first. See, normally, you teach an AI a new skill by just showing it thousands and thousands of correct examples. It's a process called supervised fine-tuning. But who on earth has the time to sit down and manually write out millions of perfect step-by-step solutions to complex math and coding problems? Nobody. It's basically impossible.
The solution came from this really key insight. For a lot of the hardest reasoning tasks, we're talking math, we're talking coding, you don't actually need a human to check the work. The answer is objectively verifiable. Does the code compile and run without errors? Yes or no? Does the math problem's final answer match the solution? Yes or no? You know for a fact if it's right or wrong.
And this insight, that's what unlocks this incredibly powerful training method called the reinforcement learning loop. It's kind of like training a dog with treats. First, the model tries to solve the problem. Second, an automated system checks if the final answer is correct. Third, if it's right, it gets a reward, a little digital treat. If it's wrong, it gets nothing. And finally, the model adjusts its own internal wiring to favor the thought processes that led to that treat. You just do this over and over, billions of times, and the model gets insanely good at reasoning.
Now, this new training method, it didn't just lead to a small improvement. No, this sparked a full-blown revolution. All of a sudden, it felt like every AI lab on the planet cracked the code at the same time, leading to this rapid explosion of incredibly powerful new models.
I mean, just look at this timeline. This isn't ancient history we're talking about. This has all happened basically in the last year or so. Starting in late 2024, every single major player in AI started dropping these models with advanced reasoning. It went from a niche research concept to a mainstream feature almost overnight. It's been wild.
So what does a state-of-the-art recipe for one of these models actually look like? Well, the DeepSync R1 paper gave us a fantastic blueprint. You start by teaching the model the basic format of how to think using a small, super clean dataset. Then, you hit it hard with that reinforcement learning loop to build up its core reasoning muscles for math and code. After that, you mix that new skill with all the normal conversational data so it's still a good all-around assistant. And then finally, you do one last round of RL to polish everything up.
Okay, so these models are way smarter. They can solve much harder problems. But what does this actually mean for us, the people using them every day? Well, all this new power comes with a pretty practical implication, a sort of hidden cost that you might have already noticed.
Have you ever been using a chatbot and you see that little message pop up that says thinking before it spits out an answer? Yeah, that's not just some cute little animation to make you wait. That is the user interface telling you that behind the scenes, the model is busy generating that entire internal multi-step chain of thought we've been talking about this whole time. And here is the absolute kicker. That extra thinking is not free. When you use these models, you get charged based on tokens, which are basically the words and parts of words the AI is processing. And as this quote makes crystal clear, that includes all of those hidden reasoning steps, not just the final answer that you actually get to see.
So what this does is it creates a whole new cost-benefit trade-off for everyone. A standard vanilla LLM is going to be cheaper to run for sure, but it's limited to more basic tasks. A reasoning LLM, on the other hand, can perform that advanced logic, but all of that extra computation, all that thinking, it costs more. We're now seeing a new tier of AI performance, and with it, a new tier of cost.
And that brings us to our final question for today. As this incredibly powerful technology keeps getting better and better, who's actually going to have access to it? Is the ability to ask an AI to solve the truly difficult problems, the ones that require deep, multi-step reasoning, is that going to become a premium feature? A luxury that's only reserved for people who can afford to pay for the extra cost of thinking? It's definitely something to ponder. Thanks for watching.